I'm Jay Grymes. Some of you may know me from television. If you don't, then you're watching the wrong damn channel. Again, as Renee mentioned, I've spent 20 years actually with LSU before I crossed over to the dark side. Been with the television station now for a little over 20 years. And kind of uniquely and surprisingly, I've been, it's like The Godfather. They pulled me back in. So I'm actually going back over to LSU part-time for the next 3 to 6 months or so while we try and sort of reorganize and redefine weather services out of LSU. So especially for any of the parish agents that might be here, what I'm looking to do in the coming months is to get the parish agents much more involved, and I'm going to show you exactly where their activity can be helpful. This is a model run for the rain that is just about overhead right now. By the way, I timed this out perfectly, don't you think? It's been a rocky 2023 and certainly into 2024 here. Now we're dealing with the heavy rains that are going to be hitting much of the state, not just today, yesterday, today, and the next day or two, but it could be a rather damp spring. I want you to get ready for that. We're going to talk about that as we go forward. So I'm not going to, I'm chickening out here. I'm not going to give you a forecast. I'm going to do climate. I'm going to tell you what happened, less so than what will be happening. But they're linked together. In fact, to be a good climate scientist, you've got to be a good weather person. You've got to understand the processes. So let's get through it first. And here is kind of, to me, the interesting or most interesting story from a Louisiana perspective for 2023. You look at this country in terms of drought. Now, this is the beginning of this year, as of last week. By the way, if we'd had this meeting in the afternoon, I would have this map updated. For those of you that follow the drought monitor, it's officially posted each Thursday morning. So I left Baton Rouge waiting for the product. It's probably either online now, available, or will be within the next hour or so. And what you're going to see is that the drought threat in Louisiana will have come down even more. We'll talk about some details of the drought monitor here shortly, because that has actually been a big player in the AgCenter and the LSU system, bringing me back into the for the next couple of months. But the thing that's been really interesting here is that when you look at the country, the worst drought has been in the wettest part of the U.S. For those of you that may not be aware, the Gulf Coast region is the wettest part of the lower 48. We get more rain down here than anybody else. In fact, Louisiana is the wettest state in the lower 48, and you live in the wettest part of the wettest state. So the fact that we had drought and intense drought last year is really fairly unique, and it's also kind of, and you'll understand this, when you talk to people in Texas and Arizona, they chuckle at what we call drought when we're just talking about rainfall. But it's because your agricultural focus is built around normal rainfall here. For them, that would be a wet year, a normal rainfall here. So we'll get back to the drought monitor here in a second. I'm going to run through a couple of quick maps here. What I'm going to show you is the maps of 180-day, 90-day, 30-day rainfall. But really what's more important, because these don't tell us a lot, but what's really more important is looking at the departure for normal, or the percentage of normal. So here's the 180-day map, percentage of normal. And across the state, you see that most of the state was somewhere between 50 and 100% of normal rainfall. Well, that doesn't sound all that bad, but 50% or even 70% of normal rainfall in the summer can be problematic, particularly when we have a summer like this last one, which was not only dry, but it was unusually hot and unusually sunny. 90-day precipitation, same look here, the 90-day percentage of normal. Now, down in your neck of the woods, rainfall over the last 90 days, not so bad, but a lot of that is because of what's come over the last 45 days or so. You are still suffering from some moisture shortages heading into the fall. Then we get to the 30-day numbers, and now we're looking at some rainfall percentages that are running well above normal across the southern grid. By the way, the other thing I want you to notice, and when you look at rainfall estimates, including the stuff that I show for the extreme southeastern parishes, take those with a grain of salt, because my opinion is that the radar estimates, and by the way, these are radar estimates. See, weather affects everything. The radar estimates are lower than they should be. Anybody have a guess as to why that is? What has changed in terms of regional radar service?
You've got a new tower around St. Francisville, didn't you? Slide L is up.
It's the Slide L issue. The National Weather Service radar in Slide L is offline right now. The radar is being moved, it's in the process of being moved from Slide L to Hammond. Now in the end, the service for you won't change at all. So you'll still have good quality service. But what's happening right now, and has been happening since the radar went offline a few weeks ago, is that radar coverage down in this part of the state is dependent upon radar in Mobile and radar in Fort Polk or Fort Johnson. Those radars are too far away to give us a really good radar reflection, particularly when we use radar to estimate rainfall. And the reason for that is, the farther away the radar is, the higher the beam is over your area. So think of the radar, it's like a flashlight shining across the horizon. But the curvature of the Earth means that the farther away from the radar site you are, the higher the beam is above the ground. And when we use radar for rainfall, we want the lowest beam possible. Well, Mobile and Fort Johnson are just too far away to really give us a good feel for the radar down here, the radar and rain estimates there. Now, some of you may be aware that WAFB has partnered with a company called Climatologist. And just like you maybe rent a tractor, we're effectively renting 3 small radars. One up in West Louisiana Parish, one in St. Mary Parish, and the latest one just to come online down in Chauvin. Those give us a good reflection of what's going on in terms of the active weather. But because they're a private radar service, we can't get that data into the Weather Service's analysis of rainfall estimates. So even though we've got a reasonably good rainfall coverage, radar coverage for your area from radar right here, that's certainly capturing that. Plus we've also got the radar here in Franklin. Both of those are overlapping, giving us a good picture of what's going on over Assumption Parish, but they don't allow us to estimate rains. And back again, for areas, especially east of Chauvin, undercovered there. So just a heads up, whenever you see the radar estimates for the southeastern parishes, be aware that those numbers may be a little on the low side. And then finally, the 7-day rains, and you see what's happened in Texas. We're talking about 6, 8, 10 inches of rain over there over the last couple of days. Unfortunately, this product was only updated through yesterday morning, so it's missing the rainfall that we've had here. But for those of you who have been watching, we've had 6 to 10 inches of rain in St. Landry, Point Coupee Parish, extreme southeastern of Wills Parish. So there's some big flooding going on not too far to the north. You have kind of missed out on that heavy stuff, but coming down here I could see you got pounded pretty well yesterday, and there's still more to come. What's going on overhead right now, although that should get in and out fairly quickly, but there's scattered rains again on Friday, and then there's going to be another line that may not be all that different from what we're getting right now. That's going to come through Saturday morning. So we've still probably got as much as another 2 to possibly 4 inches of rain between now and midday Saturday to come. So just sort of keep that in mind. All right, back to this drought monitor. First of all, how many of you are aware of the drought monitor? Just show of hands. How many of you actually use it for anything, even if just thinking? Okay, all right, decent number of hands. All right, now here's the thing. Have you ever actually wondered where this comes from? Who does it? How does it work? What does it mean? And if you're a user of this product, you need to know the answer to all of those. Because first off, it's produced once a week. It's released officially on Thursday morning. Why Thursday morning? Well, because when we used to release it earlier than that, and this was more than a decade ago, almost 2 decades ago, it would come out before the Chicago commodities market hit, and it would change, actually have an impact on the commodities market. And in fact, there are a lot of decisions that are based on that product, including in some cases, whether federal assistance is available to you. And this actually became a big issue this past summer. So it comes out on Thursday morning. But the update for the information that goes into it is only through Tuesday morning. So when you get it, it's already 2 days behind. So a lot of times, especially in weather like we've had here, the rain we had yesterday will not be included in this morning's drought monitor. So you got to keep that in mind. It's not as timely as you would like. Secondly, and more importantly, and this is what really became an issue for particularly some North Louisiana producers, if you think this is like a science product or a model product, it's not really. About half of the information that goes into it is a variety of different types of information, including rainfall over the last 7 days to the last 90 days, estimates of evapotranspiration, but in the very end, it's a human product where a group of people make a decision as to whether they're going to call an area drought 1, drought 2, drought 3. Well, drought 3 is the trigger for a lot of federal assistance. So the problem becomes, if this group of people doesn't get together on Monday or Tuesday afternoon, the drought monitor doesn't get updated. And what happened over the past summer was the drought monitor was allowed to slip a little bit behind the reality of the drought situation in Louisiana. Realistically, this was one of the worst droughts we've had in Louisiana in at least a decade, and arguably one of the 4 or 5 worst decades in the last 100 droughts in the last 100 years. Well, when the curve gets a little bit behind and people start looking for the assistance that they think they should qualify for and can't get it because this product hasn't been updated, somebody gets pretty angry. A lot of people got pretty angry. So this is why I'm reaching out to the parish agents. What I'm looking for is for the parish agents across the state to be a little bit more proactive with this product. Because I can run, and you guys are fully aware of this, I can run all the computer models I can get my hands on. But in the end, feet on the ground will tell me how dry or how wet it is in the parish. Not some computer model run in Washington that basically works like a roller on a paintbrush and covers multiple parishes in a single swath. And that's what we've got here. This isn't looking at Assumption Parish uniquely or Livingston Parish uniquely. It's looking at a regional pattern. So if I can get input from the parish agents who get input from you, then I may be able to have a better sense of reflecting what's going on down here locally than just what some regional computer model would say. So what I'm hoping is you will interact more directly at times, particularly in critical weather periods, with your parish agent, and that agent will interact with LSU in a way that we get a better product here on a weekly basis. Now, it's never going to be perfect, and you know full well that there are times where your property is markedly different than 3 miles down the road. But that goes into the thought process too. So we're looking to fix the problems that we've had with the drought monitor. By the way, going back into last year, coming out of the spring, The winter spring last year was on the wet side, just about statewide. And so you can see here, this is as of the first week of March. Really, the state was in pretty good shape, at least no drought. In fact, there were places where it was too wet. And by the way, there's a drought monitor, there is not a too wet monitor. So we don't have a tool that lets us say, hey, it's way too wet here. But the drought monitor does give us a sense of where we're getting the dryness. And you see what happened going from the first week of March to the last week of November. Now, by the end of November, the drought monitor had caught up to where it needed to be. The problem was from July to September, it was behind the curve. And that's where particularly some North Louisiana producers got very, very perturbed, and that's a very kind word for what really they did, about where the drought monitor was. So we're going to hopefully fix that problem. And in fact, again, this was a critically dry summer for us, near record temperatures seasonally, even though on a day-by-day basis, we didn't see a whole lot of record-breaking highs. But on a weekly and monthly basis, we saw a lot of records there. And it was a two-factor thing. One is we didn't get the rain. That's obviously going to create the drought. But high pressure, and now if you were following your local TV folks, me hopefully, or us, Channel 9, but whoever you were watching, we were focusing on the fact that there was this ridge of high pressure that was parked over the southwestern and south central states for a good bit of the summer. And what that does is it not only knocks down rain chances, but it also even knocks down cloud cover. Less cloud cover means more sunshine. More sunshine not only means more daytime heat, but it also means increased evaporation. So you had this sort of triple whammy factor, lack of rain plus too much sunshine, that dried things out even more critically than it might have had it been just a shortage of rainfall alone. This is a timeline for the drought monitor. Now it's statewide, and we can actually break this down a little bit more regionally. But what I want you to notice is, anywhere you see this cluster, that's a drought period, a significant drought period. Now the drought monitor, unfortunately, is a relatively new tool. It's only, historical records for it only go back to about 1999 or so. So that's why I didn't go deeper into the past. But you can see, since 2000, we've had really 3, maybe 4 significant droughts. And this one has been, in some ways, the most intense of them all. The drought of 2011-2012 was the longest lasting, and the advantage for us right now is it looks like we're about ready to close the door on the drought right now, or we'll be doing so in the next couple of weeks, and I'll show you why here in a minute. So we won't get anywhere near this kind of duration, but in terms of the intensity, and you can determine the intensity by the deeper shades. Almost, for you, it probably almost looks black back there, or a very, very deep red. Statewide, this was probably the most widespread drought of critical drought conditions that we've had based upon the drought monitor. So we get these flip-flops in drought conditions. Now the thing is, we know what the mechanism was that created the drought this summer, but what we don't know is why it was there. Why was that high so persistent? There'll be people writing dissertations about that in the coming years, I can promise you. But it was certainly an anomaly that impacted the central Gulf Coast region. But what was really strange about it is you don't have to go very far east of us, and they were getting rain just fine. And what was happening was that range of high pressure was like an umbrella that kept rain out of the area. But the edge of the umbrella kind of ran through Mississippi, and everything east of Mississippi wasn't impacted by that high pressure ridge. Everything from Louisiana westward got caught in it. And even though Texas was dry, it wasn't unusually dry. For us, it was, in some instances, near record drought. So that you see here that they've got a number of droughts going back over that period of time. And it certainly, this may be the most intense, but not the longest, over the last 2 decades or so. I said this at the top, and just a reminder, we live in the wettest state in the lower 48. Statistically, Hawaii is wetter, but who cares? Outside of that, you live and work in an environment that, in large part, your agricultural decisions are based upon expecting a wet period, especially in the summer months. And as it's also said, you live in the wettest part of the wettest state in the United States. You average 60 to 70 inches of rain per year. And it's a little bit greater in the summer months, but it's pretty well spread normally across the course of a year. You'll notice by a pretty significant rainfall gradient. So we're talking about 60 to 70 inches down here in the southeastern part of the state, but in the northwestern corner of the state, there are places that get less than 45 to 50 inches of rain a year. So a 20-inch gradient across the state not only changes the agricultural activities, but I'd even argue it kind of explains Louisiana's civil war between the South and the North. I mean, even culturally, we're a little bit different than our friends up there along the I-20 corridor. So where is that big difference? If we're talking about 15 to 20 inches or more over the course of the year in terms of annual rainfall, all of it is in the summer months. So this may be a little hard to see, but what I've got is a white bar represents northwestern Louisiana, this region here, and the gray bar represents southeastern Louisiana, which includes you. And what I want you to notice is that as you look at these months, October, November, December, January, even all the way into April, May, the average rainfall month by month for the Northwest and Southeast are fairly similar. There's not all that big a difference. The big difference is in those summer months, where South Louisiana gets twice the rainfall as our friends in the northern part of the state. Now, a lot of people say, oh, that's tropical weather. No, it's not. Tropics really don't play that big a role in our average or our normal rainfall numbers. They have a big role in an annual number, especially when we get 20 or 30 inches of rain in a period of 5 or 10 days. But when we average it out over 30 years, those tropical systems kind of get washed out of the equation. This is all about those afternoon summer thunder showers that we get, that drift in off of the Gulf of Mexico and build up because of the daytime heating and humidity. But as they travel northward during the day, they rain themselves out. And so those same individual storms that lift slowly northward, in fact, you probably heard your TV guys say the sea breeze. That's that band of showers, and sometimes it's very, very evident. Other times it's a little fuzzier to pick out. But it's a band of thunderstorms that drift inland during the day. But as an individual thunderstorm, it's like a water bag. It only has so much water, and at some point, it rains itself out. And those thunderstorms collapse before they get to Alexandria. So we have this summertime pattern of very wet, hit and miss afternoon thunder showers in the southern part of the state that just almost never make it into the northern part of the state, and that explains the difference. That explains why you're doing sugarcane, not cotton. All right, let's change gears a little bit. El Nino Southern Oscillation. El Nino, how many have heard of it? Remember, everything that goes wrong is El Nino. Take that one home. If the Tigers lose tonight, it's the El Nino. But there is a player. El Nino does play an important role in our weather, both in the winter, spring, and in the summer. And we'll talk about that here in a second. So what is it first? El Nino and Southern Oscillation, it's an ocean-atmosphere linkage. So we're looking at how the ocean and the atmosphere interact with one another. And for those of you that reach back into your ninth grade physical science class, you may remember that even air is a liquid. from a physics standpoint, all the rules of water apply to air. Air is just a really thin, less dense liquid. So we've got one liquid laying on top of the other. The air, the atmosphere, one liquid laying on top of the ocean. And just like that seesaw thing at Spencer's Gift at the mall, you ever see it? The one that has the blue water on the bottom and the clear on the top. Whenever the blue moves, it affects how the clear water on the top behaves. So change the ocean, you change the atmosphere. Change the atmosphere, you also change the ocean. So these two layers are interacting one with the other. So that's what we're talking about there. And they create what we call teleconnections. Teleconnections is a fancy word for if this happens in Napoleonville, this always happens in reserve. How changes at one location are associated with changes in another. What we're going to focus on with El Nino is how changes over the Pacific Ocean affect our weather here 2,000 miles away. And the first thought should be, how can that be possible? Well, it's because changes in the Pacific Ocean affect the atmosphere above it, and that atmospheric energy travels west to east and has an impact on us. So we have El Nino and El Nino's evil sister, La Nina. And these are flip-flops, kind of like kids on a teeter-totter, a seesaw, that change the ocean temperature signature. El Nino is when the Pacific Ocean along the equator is warmer than normal. La Nina, the flip side, is when the water is cooler than normal. Both of those impact our local weather. And the Southern Oscillation, it's not something we're going to really worry that much about, but ENSO, since SO is in the ENSO acronym, the Southern Oscillation is how the pressure pattern changes. And what happens is, I'll say this once, forget about it right after. When the Pacific Ocean is warm, the pressure pattern over that area is lower, a change in the atmosphere. When the Pacific Ocean is cool, the pressure pattern over that area is higher. High pressure means fewer storms over the Pacific. Low pressure means more thunderstorms over the Central Pacific. And those thunderstorms clustered over the Pacific kind of act like a rock thrown into a creek. The creek's flowing along, you drop a rock in it, what happens to the water flow? It's got to go around the rock, right? That little ripple sends energy pulses downstream. When we change the behavior of the ocean in the Pacific, we change the behavior of the atmosphere above it, and that changes the impulses that head downstream. That's why El Nino ENSO is important for us. Now, I just want you to remember this graphic here. El Nino is when we have warm water along the equator. Get your bearings here. There's the coast, there's Western South America, Central America, the Southern United States. One of the things that happens in the winter is that when the water in the equatorial Pacific is warmer than normal, we get a more active subtropical jet stream flow in the atmosphere at the mid and upper levels. So I'm talking about flow in the atmosphere 2, 3, 5 miles above the surface. Now, why is that important? Because an active jet stream flowing over the Gulf of Mexico creates more Gulf lows. Now, keep in mind, this is wintertime. These aren't tropical lows. These aren't tropical systems. These are non-tropical, basically winter storm systems. But when we get lows in the northwestern Gulf, we get wet. In La Nina, everything changes. This becomes cool, that goes away, fewer Gulf lows. So in El Ninos, in the winter, we tend to be wetter than normal. In La Ninas, in the winter, we tend to be drier than normal. So this is a long-term record of El Nino and La Nina. Red is El Nino, warm water in the Central Pacific. Blue is La Nina, cold water in the Pacific. Now, I think you can see there's a flip-flop, right? The problem is the flip-flop isn't even like two kids on a teeter-totter. If it was, we could predict it right on the nose. But you'll notice a couple of things. That sometimes the teeter is long-lasting, sometimes it hardly lasts much at all. And the duration doesn't necessarily reflect the intensity. Yeah, so for example, here is a longer duration event than this one, but this one was more intense. So there's a lot of still what-ifs going on in this flip-flop between El Nino and La Nina. Well, when you look at that, you go, okay, so everything is either El Nino or La Nina. No. One of the things we do as scientists to make everything as confusing as possible is we add in another factor. So where I've drawn in that black bar, we're going to call that near normal. And for kicks, we've even called it La Nada, the nothing. So you got El Nino warm, La Nina cool, and the nothing. Well, the fact of the matter is, the nothing occurs about 50% of the time. So when we take away all of the time that's in under this black, now you really see that flip-flop pattern. And one of the things you may also notice is that over time, and it's not evident here so much, but if we went back in time, you would also notice another cycle in here that suggested that there are runs of decades where, even though the flip-flop is going on, El Nino predominates. And then another couple of decades where the flip-flop is still going on, but we have more La Nina years. We've actually been in a period where La Nina has been a little bit more active over the last decade or two. But you see, here we are, this is our current status right now, with a fairly significant El Nino, thank you. But it is, again, going to come to an end very shortly here as we get into the spring. But anyway, you see the flip-flop there, and I just want you to notice, and remember, years with El Nino or wet, years with La Nina in the spring, or summer, winter, and spring, they're dry. So let's go ahead and take a look at what's going on out in the Pacific right now. Get your bearings here. Australia, South America, Central America, Florida Peninsula. This is a weekly rendition of average water temperatures in the Pacific. Now, this really doesn't help us out at all. But what I just want to show this is, notice how the warmest waters in the Pacific are all in the Western Pacific. And the reason I'm kind of telling you that is because what happens when you heat something up? Does it swell or shrink? Swells. So the Pacific Ocean is tilted. The Western Pacific is actually as much as a half a meter to a meter higher than the Eastern Pacific just because of the water warmth. Now, what does Mother Nature want to do with that? Wants to flatten it out, right? So every once in a while, this abundance of warm water heads east. What do you think that does? What does that create? El Nino. That's right. So when that water sloshes to the east, we get an El Nino phase. But what we want to look at, not are what the actual water temperatures are. What we want to look at is what weather scientists call, and ocean scientists, the sea surface temperature, water temperature anomaly. How is it different from normal? And this is the anomaly. Now, down here, what you see is anywhere you see shades of yellow to orange to red, that's where the water temperatures are warmer than normal. And you see this big box here, and this giant tongue of very warm water. That is textbook signature for El Nino. Warmer than normal waters along the equatorial Pacific. And if you remember back to that map I showed you, where we looked at that warm tongue coming off of South America, this is the setup that creates an active subtropical jet, which tends to make for more Gulf region winter lows, which makes us wet. And in fact, when we're in El Nino, better than 70% of our winter springs, especially in South Louisiana, are wetter than normal. So this is another way of looking at it. These are computer models showing you what the computer models say the water temperatures in the Pacific, eastern equatorial Pacific are going to do. So we've been way above normal thus far, and you see that all of the models agree that it's going to be a couple of months before those water temperatures drop below the El Nino threshold. And that's probably going to happen March, April, May, June, July. We're probably going to say goodbye to El Nino at the end of the spring. Now, that's kind of a shame, because remember I said that El Nino affects us both in the winter and the summer. When El Nino persists into the summer and fall, we tend to see a decrease in tropical activity. El Nino in the summer is good for us. El Nino in the winter, not so good, because El Nino in the winter increases our flood potential dramatically across the southern parishes. So we're going to probably say goodbye to this El Nino heading into the spring, and in fact, we could be moving into a La Nina next fall. That's not good, because La Ninas typically come with a slight increase, a slight uptick in tropical activity in the Atlantic. So just to give you sort of a perspective, here are two national maps of rainfall on average from November to March during El Nino, and you see how much wetter than normal the entire Gulf Coast region is. And then La Nina, the flip side, and look how much drier than normal the Gulf Coast region is during La Ninas. That's the teleconnection we're talking about. The ability to anticipate what's going to happen in the Gulf Coast based upon something that's happening, if this was on the map, something that's happening about here on the wall, way out in the Pacific. So just a little heads up on how all that works. In terms of those numbers, now here's a look at January to April rainfall. During an El Nino versus non-El Nino years, statewide rainfall is above normal. But the impact is mostly in the southern part of the state. If we look at northwest Louisiana, El Nino doesn't play much of an impact. But in southeast Louisiana, it can almost double our winter-spring rain during this event. So what you're getting this week, something we need to at least be prepared for. Be prepared for having to manage excess water for the next 3 to 4 months at least. All right, here's a quick look at what the Weather Prediction Center, the Weather Service's climate group that gives out forecasts for 1 and 3 month estimates of rainfall and temperature. How many of you look at these? Anybody look at these long range forecasts? Okay, how many of you find them useful? Well, hell, I don't even find them useful. But that's what they are. It is what it is. So what I want you to notice, here is the monthly temperature forecast for February. And you see across the country, it's saying that February is expected to likely be, and I say likely, to be warmer than normal in the northern half of the country. Now, a couple of things here. If I told you the 30-day forecast from the Climate Prediction Center was calling for cooler than normal weather in the month of February for Louisiana, for South Louisiana, let's say, would you expect more or fewer freezes than normal? Your thought would be more, yeah. The answer is, this doesn't help us out one single bit. Even if it said it was going to be cooler than normal, it doesn't help us out one single bit. And when we look at El Ninos and La Ninas historically, for South Louisiana, it doesn't make a difference in terms of trying to anticipate how many freezes are coming. And this is kind of one of those subtle differences between climate, a monthly average temperature, which really doesn't tell you anything, and weather. Because you can have a month where the average temperature was warmer than normal, But he only had to have a 2-day Arctic outbreak, and you just had temperatures drop into the teens. And yet at the end of the month, the average temperature was still above normal. So I don't find these products really very useful at all. And by the way, where you see equal chances, that's CPC language for, we don't know. It means equal chances of being below, above, or near normal, which to me means you don't know. And that's the fact. We don't really have any skill at forecasting temperatures, even on a monthly basis, much less trying to tell you, get ready for a freeze the second week of February. I might be able to get you in that zone 10 to 12 days ahead of time, but certainly not a month ahead of time. So, historically, for Louisiana, the winter temperatures tend to be a little cooler than normal in the winter and spring. But it doesn't mean more freezes. You're going to figure this out for yourself. Why is it going to be cooler than normal in a wet period? Of course. That's why the average temperature during El Nino is cooler than normal. It's wetter than normal, more cloud cover. It just doesn't get as warm during the day. In fact, when we have cloudy skies in the winter, what's the winter temperature more likely to be? A little on the high side, right? Cloudy nights in the winter tend to keep us warmer. So the daytime temperatures come down because of the rain, but the nighttime temperatures really don't change much at all, and may even come up a little bit because of the cloud cover. So, short answer is, I appreciate those of you that look at this. I look at it all the time, and after I look at it, I go, okay, that was useless. What about rainfall? And look, in the bigger scheme of things, would most of you agree rainfall is your number one friend or enemy? It doesn't really have a whole lot to do with temperature, especially temperature on a seasonal basis. So what about rainfall? Well, you see, they've got it painted in that shade of green. What they're telling us is what we already know. There's an El Nino out there, it's likely to lean wet. In fact, I'll be honest with you, I'm a little surprised that they're not more aggressive in terms of the shading here. I would say, and what we got here, so where we have this light green to medium green, we're talking about a 30 to a 40% chance of being significantly above normal. And by significantly above normal, I'm talking about 2 inches or more above the monthly normal. I would put that more like 50 to 70%. But you get the idea. They're basically using El Nino as their forecast tool for the February forecast and for the 3-month February, March, April forecast. Folks, it's not rocket science. It's looking at history and saying, El Nino's back, probably going to be wet. All right, let's move along here. All right, and you keeping the time on me? How am I doing? Okay. All right, I know you all know about hurricanes, but every time I give this talk, there's somebody out there from Australia that has no idea what I'm talking about. So let's do a little hurricane 101. I want you to understand, make sure we all agree, what is a hurricane and where do they come from? If you know this, if you didn't know this before you came here, now you do. And if you knew this already, then I'm not teaching you anything. All right. Last year, we have been very lucky, but we deserve it. These last couple of decades have just been brutal on Louisiana. Last year, 20 named storms, 7 hurricanes, 3 majors. Louisiana got away unscathed for the 2nd year in a row. When we typically see 20 named storms, notice that the Gulf only had 3 storms. Now, historically, 1 in 3 named storms either end up in the Gulf of Mexico or form there. So statistics tells us that instead of these 3, we should have had 6 or 7 storms in the Gulf. So we got lucky there. But most importantly, and as I get older, I don't care how many storms are going to form in the Atlantic. I care about how many are coming here. And the truth is, that number, even at the beginning of the season, where you've got all these experts throwing out, 15 to 20, 12 to 14. I mean, great, it's great coffee table fodder. You can chat it up all you want. It doesn't tell you jack about the threat to Louisiana. What you need to know, and most of you are already aware of this, is that this state is one of the most frequently impacted states in the country when it comes to tropical weather. Now, I say that, if you were to pick a state and say that state deserves the nickname the hurricane state, which one would it be? Florida. It's not a tough question. Of course it's Florida. But here's why it's Florida. Florida has essentially three coasts: the Atlantic coast, the Tampa Gulf Coast, and the Pensacola Gulf Coast. They've got 1,200 miles of coastline that's this big, narrow nose sticking out in the Atlantic Ocean saying, hit me. Of course they're going to get hit. Louisiana's coastline is only a third the length of Florida's. But you know, per mile of coastline, Louisiana gets hit 1.5 times more frequently. And over the last 20 years, we're running just about neck and neck with Florida in terms of named storms making an impact. I don't know what you guys have done, but the Almighty is not happy with you. So you notice that August and September accounts for almost 2/3 of our hits. But you can't wait till then. We've had storms as early as June. In fact, the earliest storm to hit Louisiana actually came the last week of May. So we have a pretty full season. And over that time period, we've had about 90 storms hit Louisiana over the last 120 years. Here's a breakdown of all the storms over that time period. Orange represents tropical storms. Red indicates hurricanes stacked on top of each other. You get the number of named storms per season. I think a couple things should be jumping out at you here. Number one, there aren't a whole lot of quiet years. There's certainly a lot of activity there. Number two, like I said before, I don't know what you guys have done, but you've gotten the Almighty's attention. 27 named storms in the last 23 years. We're averaging better than one storm a year over the last 2 decades. And when we look at those, it has been just nuts. Look at this. This is since 2001. I'm missing the last 2 years here, but I'm not really missing them because we did get lucky. We had some quiet time here. Had a nice quiet run, 13 to 16, but I'm not sure that makes up for it. 1, 2, 3, 4, 5, 6 years where we had multiple hits. We have really been taking it on the nose when it comes to the tropics, and I would argue that we're just as threatened a state as Florida. At least that's been the rule over the last couple of decades. And you can see here just some of the storm names. You know the ones you've had to deal with. And of course, most recently, 2020 just being a disastrous year across the Bayou State. We're still not recovered from that. You know, there's still people that haven't recovered from Katrina. So these aren't 2- and 3-year effective events. They can last for decades or more. All right, 2 more slides, and then I'll be glad to say I don't know to any questions that you might have. Long-term rainfall for the state as a whole. And I could break this down, but just give you sort of a guideline. Over the last 100 plus years, about 125 years, there's been a slow, slight increase in rainfall for the Bayou State. Now, whether you want to call that climate change or not, that's debatable. But there is a change, whether it's climate change or not. It is a little bit wetter, and that's probably, linked to the fact that the atmosphere, like it or not, is getting a little bit warmer. In fact, looking at Louisiana temperatures, annual temperatures up since 1975, something is going on. It is really ramping up at a very, very fast rate. In fact, it has increased so rapidly over the last 40 years that it's caught up to where it used to be. local or regional climate change. So when somebody says there's no such thing as climate change, I just look at them and go, sure, fine, that's what you think. That's climate change. It's maybe not what you're thinking of when we start talking about the globe as a whole, but there's climate variability going on all the time. Now, whether it's variability or change, that's a semantics argument. But the fact of the matter is, it's always varying, it's always changing, but there is a human role involved. And I'm going to touch on that just very, very quickly here, and now get out of your hair. So my thoughts on climate change. Is the planet warmer than it was 100, 150 years ago? Look, the evidence says very likely. Let's just go ahead and say yes, it is warmer. But we also know that there are times in the far past that it was warmer still than it is now. But that's climate change. So don't deny climate change. It doesn't mean that these scientists are hoaxsters. It just means that, yeah, there's something going on. And are humans contributing to it? Let me ask you something. What happens to a local temperature record, you think, when we go from a forest to a pasture, and then 20 years later we go from a pasture to a Walmart parking lot? It's going to get warmer, right? Now, that has nothing to do with the infernal combustion engine. That has to do with changing the landscape. And I think even down here, you guys, especially the old timers here, think of what Napoleonville looked like 40, 50 years ago, or even 30 years ago, compared to what it looks like today. More development, more hard services, more buildings. Urbanization, growth, creates warming. So, are humans impacting the warming? Yeah, absolutely. We're changing the landscape. That alone is going to have regional impacts on climate, which added up, region plus region plus region plus region, ultimately gets to hemispheric or global changes. So I would say that there is absolutely a human factor in climate change. But that said, I don't think we can really quantitatively determine how much of that warming that we've seen in the last 100 or 150 years is human. Now you have one camp that says it's virtually all human. I'm more in the camp that there's probably a significant contribution of human activity to the warmth, but we can't measure it. Because, first of all, our temperature record is not continuous. If you go back and look at temperature records 100 years ago, it's dominated by observations in Europe and the eastern United States. Today, we've got a much more global representation of temperatures, plus we're throwing in satellites that have only been playing the game since the late 70s. So we're not talking apples and oranges when we look back to 1890 and compare it to 1990 or 2023. So our ability to really evaluate the temperature change is even questionable. Now, should we be taking some actions to reduce the human impact? Come on, you know that. In fact, that's why many of you are master farmers, to reduce your impact on the environment. That's a good thing there. And can it be stopped? It can be mitigated. The impacts can be reduced. Climate change can't be stopped, because even if we were to just freeze human activity, there's still a natural signal in there that's going to create variability over time. All that said, I do think that Louisiana is quite probably, of the 50 states, the one that's going to be impacted the most by even minor amounts of climate change and variability. You've seen what it's done to the coast. A lot of that coastal impact is because of human changes to the natural events of coastal development and growth and recession. Well, we've changed how the Mississippi dumps sediment out into the Gulf, so we're changing how the Louisiana coast behaves, but we're also even impacting the state economically. How and where we impact the oil and gas industry based upon the premises of climate change and various national and international agreements is going to have a direct impact on still what happens to be one of our bigger industries, oil and gas. So we've got a lot to be concerned about in Louisiana for a number of reasons. And with that, I'll say thank you for your time, and I'll try and answer any questions you might have. Thank you.